Hi, everyone. Welcome to our webinar session today. We are going to give people just another minute or so to jump in, and then we'll get started. All right, we will kick things off. Welcome, everyone, to today's webinar session. My name is Taylor Lund. I manage the Scale CSC team here at GitLab, and I'm joined by my colleague, Sean John Hoyle, who is a customer success manager within the team as well. We're excited to have you on today for an advanced CI/CD session. Before I turn it over to Sean, I'm going to go through a couple of housekeeping items. First off, this webinar is being recorded, so you can look for that webinar recording as well as the deck to come through here in the next day or two. If you have any questions that come up throughout the session, please feel free to put those in the Q&A portion of your Zoom window. And we have some customer success managers and customer success engineers that will be able to help you out with those questions today. And then Sean will answer some questions at the end as well. With that, I will turn it over to Sean John to go through the session.
Thanks, Taylor. My name is Sean John Hoyle, and I'm a customer success manager for our strategic enterprise accounts. And I'm coming to you from San Antonio, Texas. Before joining GitLab, I was head of customer success at a startup where I created best practices for our product that we would publish and educate customers on how to utilize the product and go through improvements and things like that with their analytics so they could have more productive conversations with their counterparts and their project management teams. So that's a little bit about me, and I wanted to dive into what we're going to cover today. Share my screen. Okay, just want to make sure you can see that. Are we good? Okay.
We got you. Yep.
Cool. So today we're going to do a quick recap on CI/CD, especially with the GitLab flavor of CI/CD. Some of this terminology for the pipeline architectures that are most common, as well as some more advanced ones. So variables are important and foundational. So we're going to hit that so you can understand the rules and how to control your pipelines better, and then controlling your jobs and how they run, how to deal with artifacts as you're building code. You're storing in an artifact storage and those binaries that you're going to need for testing, and then deploying your code, and then assembling pipelines from components. So kind of modularizing your CI/CD jobs to be most effective and save a lot of time. A couple things that are out of scope is that detailed setup and configuration for CI/CD and runners. We've got a course on that, and so you can look that up in our professional services catalog, as well as in-depth use best practices for project management. We have a course on that as well. And if you're a systems administrator and you're trying to understand how to spin up GitLab and troubleshoot it, upgrade it, etc., we've got our own sysadmin training for that as well. So a couple things that are out of scope today, and I just wanted to get that disclaimer going before we dive right in. So let's take a start with what we call the GitLab flow. It's basically a branching strategy. You know how GitHub Flow and GitLab, they have their own. So for Git Flow, all our branching strategies, but this is more of a process. And I know this is a webinar about CI/CD, but we wanted to go ahead and start with the bigger picture in mind, because beyond the technology of the pipelines itself, it's a process basically to ensure that you get the most from your investment in GitLab, as well as to improve collaboration across your engineering team and other personas like security, change management, as you're actually writing and deploying code. So that's why we wanted to show this first. So this is the flow process that we recommend for DevOps teams to follow while using GitLab capabilities within a concurrent development lifecycle. So you start off with defining and managing the requirements, the desired issue that you're working on, whether it's a technical debt issue, whether it's features and bugs, or it's a security and compliance risk type issue. That's all in the backlog. So as soon as it starts to become in scope and ready for a sprint or deployment, you assign that issue. And then that's where the fun begins of creating your branch and then going off and making commits on that branch and pushing that back to the server. So we actually encourage, and we even have prompts in the UI to immediately create a merge request after you create that branch. So this works for more than just the GitLab Flow branching strategy. It works for many branching strategies as it's kind of agnostic in that reason. And so we do that so that it becomes evident to the rest of the team that, yes, I picked up this issue, and yes, I have a work in progress merge request, so that you can immediately start to bring the right stakeholders so they can see that when you push code, which will automatically trigger our CI/CD pipelines by default, unless you configure it to do it otherwise. So that every change is basically running linting, static analysis, and you're getting a really fast feedback loop that's just from the developer perspective. And then once it's ready to be reviewed by a senior developer that has maintainer privileges, then they can go and do so and be brought in with a single app mention, right? And then they can see the full history of commits and pushes that have taken place in the EMR. They can also see if a pipeline has green checks across, which tells them that it's passed the required quality gates. And then it'll spin up a live ephemeral instance in, let's say, a non-production environment. So you know if it's that type of application that you're developing, and that it can do so when we perform dynamic security testing on a running instance, and then test for cross-site scripting and dynamic attacks. So once it's good, and once it's looking good, and it's passing all these checks and the appropriate approvals, then separation of duties would actually come in at this point. So if there's any findings in those scans that require an additional person from a security group to come in and either approve it or review it, and then land in your default. So that would be once a merge request is accepted, it then runs the CD workflow for deploying into a release and packaging that up into a release and then deploying into your environment of choice. So whether that's staging then to production or what have you. So I just wanted to go ahead and start there and then give the bigger picture. So now kind of zooming into the CI/CD elements of what we just saw in the CI/CD pipeline, you know that's where you're building your application. And then behind the scenes, we're using GitLab runners, which we'll talk about in just a second. And then you're running into a live preview. So we're getting into the review app, and you have a live preview of your development branch before you even know to send it to your default branch, and then before merging it into a stable version of your application, so you can deploy it to multiple environments, such as staging and production. We also support advanced features, such as canary deployments for this incremental rollouts that you may have. And then you can also monitor performance and the status of your application as well, all within inside of GitLab. So let's look at the terminology that GitLab uses for describing and defining CI/CD pipelines. So stages, they're a logical group of jobs that pertain to a certain phase of the pipeline, and they can be run in parallel. And so what it really does is it's going to be organize all of this together, and then it's going to be a stage as a next piece down. So the stage is a local grouping of jobs that pertain to a phase of the pipeline, so they can be run in parallel, which improves the performance of your flow in that pipeline. So this is things like a stage that would be build, test, deploy. Those are all stages inside of the job itself. And then the actual task that needs to be performed, an example of that would be an NPM test or a Maven install, bash scripts, and then shell scripts. So that's really what makes up that. And what you're defining in infrastructure code using YAML files to do the environments is where you're going to actually be deploying. So it points a deployment destination in a file version, and it's all stored in the project that pertains to it. At its most basic function, the last piece is the GitLab runner. That's the infrastructure piece that executes everything you see on the left side. And you have as many runners as you do. You'll need to handle the volume and load from engineering department. You can even use your PC if you're trying to test certain things out, or if you have any specific use cases. So just keep in mind that this means the members of the project will also be using your laptop as a runner. So it's not really made for production, but if you're just trying to get a certification and get familiar and play with setting up GitLab CI, it's a great option, as you don't have to get any provisioning done in the cloud or anything with your OS teams. So the pipeline architectures that we're going to cover today, as we're doing this task, you can ask yourself, how can I use these concepts to improve my pipeline performance and functionality? So we've got 5 different flavors that we're going to start to dive into. The first one is just a basic vanilla pipeline that we're going to get into directed acyclical graphs. then parent-child pipelines within the same project, and dynamic child pipelines. And then the fifth one we're going to hit is multi-project pipelines. So starting with the simple basic pipeline, this is just a series of jobs that run independently, and you could put them on different runners, but even that would be more of an advanced than the basic setup that we're usually going to be using. Usually we'll all be in the same runner, and then all the jobs in the stage must complete successfully before moving on and proceeding to the next stage. So we'll go ahead and show you what that looks like. So a basic build, test, deploy pipeline here with all the jobs. So you can see if the build itself is successful, and then you can start to run a series of tests, probably some unit testing and integration testing here. There's also some logic, the allow failure to be true so that the pipeline can proceed, even though if it failed those tests, that's optional. And you can configure that for deployment. And it could be it's a common practice that around deploying to environments that you have the right permissions. And a lot of requirements for separation of duties say that the person who pushes the code can't deploy the code. So this is how you would handle a scenario like that. So when you're deploying into a production or even UAT or a staging environment, it will wait for somebody with the right permission to click that. The manual intervention to deploy, and then you have other options when delayed on failure. And it's always something more to control the flow of a pipeline. If you've got like hard requirements to always run something, to basically run it on a failure or delaying running a job. And that's basically the flow that it goes along through. So the second one that I wanted to mention is, this is a big architecture improvement that we made a few years ago, but it's a very foundational piece to GitLab CI, as the idea of a needs clause, or what you really need it to look like, is a directed acyclical graph, which is a DAG. So this is how you start to define the flow of the pipeline so that you can run parallel jobs, and you can even move on to the next stage when certain jobs haven't finished. So the more that you can concurrently run, the faster job or that pipeline can finish as a whole. So this is great for moving on to non-dependent jobs so that you can keep the flow moving and you don't get hung up waiting for every job in a stage to continue before moving on. So that's what the keyword allows you to do. It defines those jobs. And this is kind of what it looks like as an example of using the needs keyword. So you can define the job relationship if GitLab knows the relationship between the jobs. It can run everything as fast as possible and even skip into subsequent stages when possible. So in this example, you have an application to point towards Android and iOS. And if those aren't dependent on each other running, so you wanted to create a needs keyword here, you can speed up the total pipeline if the Android build completes first, faster than the iOS, then it can move on to the running of all the tests that build binary instead of waiting for both of them to complete. So this is a visualization, and I know it's a little bit complicated, but you can see from the beginning the flow logic by using our UI. If you look at the relationship between jobs, so if you mouse over and highlight the dependency paths involved, you can also click on multiple paths, and it's interactive. So if you're trying to figure out if you've inherited a project, it's a little complicated. And basically you're trying to just figure out what's triggering. So this is a visual way of doing so. So the third architecture we're going to take a look at is the parent-child pipelines. So within the same projects, this is very useful for running non-dependent, long-running jobs. So things like code scans or building and deploying the front-end to back-end services separately, that's when this would start to become very useful. It combines, if you combine this with the directed acyclical graph pipelines, you get the benefits of both. So it's best to use every tool at your disposal so that you can improve the efficiency of these pipelines. And it's useful to branch out long-running tasks into those separate pipelines. So that's why the parent-child architecture is very useful. So along the lines of simplicity, this feature allows you to call other YAML files from the same project so that you can solve for those issues that you may be facing, such as the stage structure of a pipeline where all the steps in a stage must be completed first before the job moves on to the next stage and begins that. What happens is it causes arbitrary waits and slows things down. So this also solves for the configuration for the single global pipeline that would become very long, right? If you've got one really long global pipeline defined, it could be very difficult to manage. So you can start to modularize by using more than one YAML file within that same project. And then you have this parent CI YAML that can call those other YAML files. So it just becomes cleaner and easier to manage, to read. So readability really improves there as well. And then imports with include keyword increase the complexity of the configuration and create the potential for namespace collision, where jobs are unintentionally duplicated. So it can solve for that as well. And what it really helps is even with the pipeline user experience, it can become, you have the ability with so many jobs and stages to work with. So it really adds more on the readability side for everyone. So you can see here in the example that we've got a build and a test deploy as the downstream pipelines, all within the same project. So you may be deploying multiple microservices and you need a different language and a different pipeline to handle each of those microservices. So that's when the parent shop pipeline becomes very useful to those downstream pipelines that are triggered. They could be running separate, but they're all from within the same project. So this is sort of the behind the scenes of how to write the file for this parent-child pipeline for, let's say, a monorepo that's deploying these microservices, like I was just showing in the example. So what it'll do is it'll run the job if there are changes in those files. So you can define, for this stage in particular, you can define it to only run if there's changes in the project dash. Any one of the files that within that project you can include from elsewhere within the project. So you don't have to worry about including it here. You can include it other sides in the project. And what that's going to do is it's going to include the appropriate downstream YAML code to run that project correctly. And then finally, the strategy to depend means on this pipeline until the other pipelines have finished. So that's sort of what the code is behind the visual that we're showing here. So number 4 is the dynamic pipeline. So this is going to be generating pipeline configuration at the build time, and it uses the generated configuration at a later stage to run as a child pipeline. Sorry about that. So it runs that as a child pipeline, and it's useful to have a single pipeline configuration with different settings to support a matrix of targets and architectures. So instead of running a child pipeline from a static YAML file, you can define a job that runs your own script to generate a YAML file directly, dynamically, which is then used to trigger the child pipeline. So this technique could be very powerful in generating pipelines targeting content that changed, or let's say you want to build a matrix of targets in architectures dynamically. So you could see this test GitLab YAML file. It's being generated dynamically, and it places a generated YAML file in the job artifact store and then references it later to actually run the pipeline that it has generated dynamically there. And the 5th architecture that we're going to cover today is the multi-project pipeline. So this is when you have a project that sits sort of on top of another project. And what you can do is other projects, you can trigger pipelines across, because everything up to this point that we've been talking about with the context of a single project or a single code repository. So there's 3 main use cases for this. And we're going to talk about, but you can specify specific branches. You can pass variables to downstream pipelines. And then if the downstream pipeline fails, it will not fail the upstream pipeline. So there's a benefit to that. And it's really useful when you're building and deploying large applications that they're made up of different components to have their own project and build pipeline. So as the title offers, you can set up live CI/CD across multiple projects so that a pipeline in one project can trigger a pipeline in another project. And you can visualize the entire pipeline in that one place, including all cross-project interdependencies when you set this up within the GitLab UI itself. So we have a job called Bridge underneath the test stage. And what this does is it triggers a pipeline in the project path from which the main branch. And it's as simple as that, but there are some other great use cases for this. And it's sort of a simple A to B is the first of the 3, where a project, it just triggers the pipeline in another project to run. such as a code project triggering a rebuild of its documentation. So it's basically a simple A to B configuration for the multi-project. And then the other one is an orchestrator project that manages the build and deploy of other multiple apps across its parent's project. And that houses the control logic. So that's orchestrating large deploys across many subsequent repositories. And then the third one is called versioning. So any variable that you need to pass to downstream pipelines, this is a great reason to use the multi-project pipeline. So when you need to pass the version number to a downstream project, you can do that with a multi-project pipeline. So this is really showing you the anatomy of how to build one of these jobs with the trigger, as referred to as the bridge job. And then you can specify the project and the branch appropriately that you can do with wildcards as well. There's a lot of stuff that you can do here, and you can actually see in the UI. And when it shows you that the downstream graphic within the GitLab UI, it's really helpful to visualize everything the parent job is kicking off for you. So with that covered, we have the 5 different architectures of GitLab CI. And if you want to learn more about that, you can go into our documentation. It's just GitLab architectures. So you can kind of read more on the examples we have and the YAML code, and then you can copy and paste and play around with that as you want. But I wanted to get into the anatomy and components. So starting with the variables, CI/CD variables are a type of environment that you can use to control the behavior of jobs and pipelines and store the values that you want to reuse and avoid hard coding values in your GitLab CI YAML file. You can use predefined CI/CD variables, and we have a very large list of those that are predefined, and you can use those as you need, or you can define custom variables. So in terms of using these and injecting them into your pipeline, you could do it a number of ways: through the UI at the project level, the group level and instance level. And you can also set variables, and we'll talk about how you can do that in a second, sort of the hierarchy of them, which one takes precedence, and if it's defined more than once, right? So you can see within the project, you can add variables. You can also enter them for the pipeline run, and then you can even use URL parameters. So it doesn't have to be hard, and you don't have to fast code. You don't have to hard code strings in there, is what I'm saying. And then with the CI/CD configuration, of course, you can define those variables, both custom and the predefined variables. So this is the inherited variables, and it's a variable that's added to an artifact in the build job script. And then this artifact is really handed down to the other jobs. As inherited variables, these take precedence over variables that were defined in the YAML file previously. So then in terms of processing, the sort of order of operations, which takes one precedence. So going from bottom to top, the top being what takes the highest precedence. And if you've defined a variable manually in the UI, or if you've made an API request for that given pipeline that's been triggered, that's going to take the highest precedence. So going down to values configured at the project level in instance, with a group coming first, and then the second instance third. So if it's an instance variable, and you have a project, it's going to choose the project variable. And if there's a conflict, then you'll have a conflict. And the values that are inherited from jobs in previous stages would be called third values in the YAML block. And in the variables blocks, it's fourth. And so the values from the GitLab predefined variables are being the fifth. So for defining the flow logic, you really need rules. And if you're thinking in terms of Jenkins, like let's say Groovy scripts to manage, you know how and when the pipelines are triggered and when they're run. So that's sort of the equivalent here. So I'll talk about the syntax of the rules, but starting with the ways that you can trigger a pipeline to run, it could be from new commits. It could be from, excuse me, it can be from new commits to a merge request, but it could also be on a branch. So it could be a new tag that you enter through these manually through the UI. And if you need to run a report or a freestyle type job, you can trigger through the UI, through an API or through a schedule. So if you're going to need to run something regularly on a 24 to 48 hour schedule, you can also do that. And then the variable for this setting is the CI pipeline source. And we'll show you some examples of where you can change it in the pipeline. So if you want to disable it running on merge requests, if you need to use that variable CI pipeline source, it would show you how you can control the pipelines when they're run. So the basics of the rule and sort of the building blocks here is that you would have the job itself being defined, and you know what you have on that run, right? Would you want this job to be kicked off? Then you would need to create the rules block with the rules keyword. And then you can define if your statements to reference variables, including predefined ones, as in this case, like the CI pipeline source, it's web. So if you're using the web IDE, then you can trigger the job to be run. Otherwise, it won't be run at all. Then as it claims here, this job will really only run when the pipeline is kicked off from the web form. So it's very simple exercise. It's just going to do a string run that says this is a job that will run when the pipeline is triggered from the web form. So it's very simple, but you can start to see the construct of a job rules block. So if a statement and then a subsequent script or action is run. So a quick reference, this is a great slide if you want to save this away for later. I have before. The clauses that you can choose from the solve, the if statement, you could also do if you know the changes are going to be made to files only, and then you can run the subsequent script. So it's very useful for improving performance of your pipelines. And then the operator, if you know, it's pretty standard for writing any kind of script, the results for when that operation is true, and then what happens as a result. So the win is options you can have as always, never, on, success, etc. This is kind of the building blocks of writing in rules so that you can ensure that those things only run when they need to. And that saves time and resources and improves efficiency for your team. So here are some tips and tricks for speeding up complex pipelines. Earlier, when we looked at the directed acyclical graph, it's a great way of doing that, but let's take a look at some of the other ways that I've covered rules and variables. So the first one is setting run rules. And this is one of the favorites from the team. Basically, it allows you to say that these files didn't change, so I don't want to run this job. Or I only want to run on certain branches. And this allows you to say what jobs run. So you can say time, especially as you get a live CI YAML file. It can be over 1,000 lines sometimes, and you certainly don't want that running every single time. So setting up the cache setup, if you know that files live on the runners and it enables the use of existing built item without rebuilding it between pipelines, between pipeline runs. And tags are especially useful as you can ensure the correct runner is being utilized for the right deployment. This also allows other teams to see what they need to be running and what other teams are running as well. And parallel testing. So this one's probably self-explanatory, but I wanted to make a point to mention that as you bump up the number of tests that can be run in parallel, assuming you've already sized your runners to handle that, it's going to improve the performance. And then the performance that before script, if you have a lot of, say, like container preparation build up in a previous script, it might be a sign that you need to convert that section into a Docker file and maybe a new repo and have your own build container. But if there's any other type of scripts that is just checking for certain settings, this can dramatically accelerate builds where there are a lot of build dependencies to wear on before running your code. And one more thing I want to say about this is trying it both ways, it allows you to compare and contrast which ways run fastest for you. And I think it's just a good rule of thumb so that you can get used to using more complex concepts. But then you're very pragmatic and you're not really going to use it because it's new and cool, but rather it's more about improving the performance that you can measure and see it between different pipeline builds. So I would encourage you to take a look at that. So let's look at a couple of examples of rules and actions. So if you're trying to control when a merge request pipeline runs, if you don't want to run your CI pipeline every time, a merge request event happens and you can set that rule if you want it to run. Then you can use the CI pipeline source on a merge request event or a CI pipeline source as a way to push to that branch so that that would then trigger it unless you say otherwise, you don't have to use that. So in this example, it's pretty simple, but what it's saying is that these are the sources in which I want to run my pipeline. And here's another example where if you don't want to run a pipeline, if it was scheduled versus triggered automatically. So using the CI pipeline source for this and then saying on a merge request events, you don't want it to run. And then on a CI pipeline source schedule, you also don't want it to run. Otherwise, this job will run if the previous stage was successful. So this can just, again, save time or even control the type of tests and jobs that won't run if it's a schedule and if it's on a scheduled job. Or if it's, say, you wanted to kick it off from the UI, and you don't need it to run a whole slate or a whole block of code to save time. So basically what you're looking at is you're only trying to scan a binary, and then you're pulling it in as a dependency, and you just want it to run like a dependency scan that you don't need, maybe say full SAST, and you don't need to do secret detection on. So there's a bunch of different options, but basically what you're trying to do is cut out some of that and then dictate, do not run on this block if it's triggered manually through the UI or something like that. So I just wanted to share that as a second example. And then as the third example, if you're trying to control when scans are run based off the contents of that commit or of that merge request, this is how you would go about doing so. So if you've got a Docker file and scripts for Dockerizing your applications that have changed, then you're going to want to run my container scanning, and I'm going to want to run infrastructure as code scanning. Otherwise, I may not need to run IAC because that's all Java code and that was changed and it's not infrastructure code, right? So I can dictate that if those files aren't changed, then I can skip and save time on my pipeline. And so that's why I think that this change is a really good one. It saves time and speeds up pipelines here and there. And what this one is saying is that it needs a manual intervention to run this. If it senses a change to a Docker file or any files in those Docker scripts, then it would be a manual job. So I think this was the last one, so I went ahead and skipped forward. Sorry about that. But this is example 4. So the fourth example is sort of a delayed job. So this job is going to run for 3 hours. After it's triggered, it'll be allowed to fail. So if you let's say you have a long running either script or it's a custom long running integration test, something that you want to take a while, but the feedback isn't really necessary, like immediately, then you can start a run in a delayed or in 3 hours. So what it does is it runs either at night or a time when you know it's not going to block progress during the day when you're working on this branch. So this one, the workflow rules, they control when the entire pipeline will run, and they're outside of the job definitions. So we've been mainly talking about up to this point where if we see the commit message contains whip-whip, then it won't run the pipeline. And if a tag was applied, then it also won't run that either. Otherwise, it will, so you can control that. So what I'm saying is if this says whip, I just want to check it in and maybe have somebody on my team take a look at it. I don't actually need to run that entire pipeline on this. So this is really a technique that you can use to kind of control your workflow. And then another example for your workflow is for variables, is that this variable in this example of the Docker file, it will be set differently based on the rules. So you can see that here, it will always run, and you know by using the keyword when always. So the second to last topic I wanted to get to is artifacts. So as you know, you can run pipelines, especially CI, you're building and publishing files. Those generate files, binaries, and packages that you'll use for deploying your application. It also generates artifacts for reviewing test results. So we're going to talk about managing those artifacts for a minute. GitLab allows for saving artifacts in local or object storage, and then you can use them in subsequent jobs. And you can also use the rules of logic to exclude depends and when to control what is added. And that allows you to determine if an artifact is stored or not. So you may not need to store it. It may be something that you just need in that job to run in your tests, and that's good enough. So some of the keywords around using exclude to limit what is added, and then using depends to limit what gets downloaded on subsequent jobs. That will allow you to determine if artifacts will be stored or not. And then the expire and to determine when artifacts would be destroyed if you don't want to keep them around, which is very good to have, especially for stuff like test results. I think those are only stored for 48 to 72 hours by default. So you would have to change that and expire it if you want it to live past the default. And that's really just to save space and cost for storage. But again, you can set those differently if you need to. So where to find and download artifacts in the GitLab UI. So within the CI points page, you can see that you can download the artifacts, whether it's the compiled code or whether it's the test results that you could do on the jobs page within a specific job. And then the artifact browser, if you're using our package registry, you can download it from there. If you're using something external, you would just be sending it off to something like Artifactory, and it wouldn't be in our artifact browser. But otherwise, you would see those pipelines and the jobs themselves. So you can download those and you can review the test results if you need to. As far as administration goes, in a self-managed GitLab instance, job artifacts, they can be sorted either local or object artifact expiration. They can be configured at the instance level. And then artifact demos fall under our GitLab access control. And it's pretty small, but I'll just tell you right now, download and browse job artifacts all the way through. They go through guests and then through reporter, developer, maintainer, and owner, so that they can browse and then download job artifacts. So it's good to understand the permission structure of who has access. And that's assuming that they already have access to the project. But basically, you just want to make sure that you have this set up so that no one can just, do whatever they want and that they have the actual permissions that they need to do their job. So here are some of the container and language specific package registries that GitLab support container of use, dependency proxy, and then we have some language specific package registries. All of the common ones we have, npm, NuGet, Go, you can see here. And we also have a docs page. So if you go to our sites and you look under packages, you can find the full list and the details if you want any more information, just to dig around a little bit. So lastly, a quick example of a doc by default. All artifacts from previous stages are passed on to the next stage, but you can use a dependencies parameter to define a limited list of jobs or no jobs to fetch artifacts from. So you can use this feature to define dependencies in context of the job. And then you can also pass a list of all those previous jobs from which that artifact should be downloaded. So you can see here in this example that we've got a build OS X and build Linux stages and in order to run those test scripts. And then what we've got to do is make sure that we're using the right artifact. So that's what the dependencies of build OS X come in to play. So for the test stage, that's what you would write for as a dependency. And then likewise for your Linux testing to take place, and then make sure you're dependent on that build Linux artifact there. So this is just an example of how you can use and choose when to pass those artifacts through. And you can also have multiple generated and pass the specific jobs in those the next stage that you need. So the last but super crucial one is the extends and includes. It's super powerful. And if you take anything away from this whole presentation, I would say that this is a big one just in terms of scaling GitLab CI/CD. It's a must, and that's why I think we've covered it here. We're hitting on it towards the end, and it's building upon the concepts that we've covered previously. So an include statement is really how you bring in external YAML files to your GitLab CI configuration. It's helpful because it allows you to extract common components and improve readability, and it can save you a ton of time. So if you utilize other templates that GitLab comes with, it has a mini templates as part of your install. So all of our out-of-the-box tests like SAS, secret detection, you can use an include statement. And that's all you have to do to pick up the appropriate language of your code that was written in, and it scans for all of the SAS rules in that example. Secret detection, it does the same thing, and that it's not language dependent, but you can just add the include statement for secret detection. And then, basically it's going to take care of the rest. I think it's 2 lines of code, and that's why it's so powerful. It saves a lot of time, makes you all more efficient. And there's a couple different methods for doing this that I talked about in the templates, which are provided by GitLab at the very bottom. But you can also include a file from your local project repository. And so that's sort of the parent-child example I gave in the architects up there. There's 5 different architectures of writing a pipeline. So that's the local include. And if you're just trying to find it within your own project file, you want to include a file from a different project repository, and then remote if you want to include a file from a remote URL. So if there's something that's publicly out there, like a public gitlab.com that you want to pipe in, it needs to be public visibility or have public visibility first. But you can do that. And then here's the examples on the syntax for writing those includes. So extends is another way to improve efficiency and eliminate needs for rewriting or writing lengthy code in your YAML file. So what it does is it extends is similar to GitLab anchors or YAML anchors. It's a little bit more flexible and readable. So I did want to touch on this a little bit. And what it'll allow you to do is enhance and reuse configuration sections. So if you know about YAML anchors, you know that it's used to duplicate or inherit across your YAML file, but they're really only valid in the file they were defined. So that's where the extend comes in, and you can inherit up to 11 levels. But I believe in our documentation, we say no more than just 3 for performance reasons. So if you start to see problems, that's probably why. And that's why we recommend 3 instead of 11. And then what it really does is it merges the configurations from the respective jobs into your current one. And then that's really where it's going to save you time. So that's kind of the example you see here with the dot tests in our spec becoming one single job. And then that's been extended from the template job. And this really works across configuration files when you use and include with an extend. So in this example, you can include an external include file and then a nice little script that says you can include that in your GitLab CI YAML file. So instead of having to copy and paste and complicate your GitLab CI YAML files, you can create a job that extends that .template job with the scripts echo hello and just say what image you want it to run. So for a simple example, this is kind of it, right? But it's a powerful feature, and I wanted to make sure that we called it out here. So I think we have about 10 more minutes here, and I know we've covered a lot of ground, specifically about components and reusability, but I just wanted to kick it over to Taylor for some questions.
Awesome. Thanks, John. So before I jump into the questions, just an FYI, I just opened up a feedback poll. So if everyone could take just a quick second to fill out those couple of questions, that would be great. We'd love to get your feedback. With that, I'll ask a couple of questions that have come through. The first is, what is the use of include in GitLab?
Sure. So for includes for GitLab, you can use an include to include external YAML files in your CI/CD jobs. It gives you a couple options. You can include a single configuration file, an array of files, a default config file, and then you can also overwrite included configuration values and arrays, or you can also use nested includes. So those would probably be the top uses for including GitLab.
Awesome. Next one here. When should I use a child pipeline?
You would want to use a child pipeline when you have a GitLab parent-child pipeline under the same GitLab project. So I guess the main thing it would be useful for is when you want to run your pipeline under multiple conditions, and you may want to run your pipeline on multiple merge requests, issue events, and push files. So if that's the example that you have, then that would be a good use of a child pipeline.
Great. Last one I'm seeing here. Why do we use pipeline in GitLab?
So the reason why you want to do that is teams can configure builds and tests as a team. Basically, they can write that pipeline as a code, and then you can track that and store it in a central repo. So that allows teams to basically store all their info together, and then they can use a YAML file to approach any kind of language that they have from Jenkins or anything like that. But the premise remains the same, that team can all work together and all their work is saved together.
Awesome. Thanks, John. With that, we'll wrap up today. Thanks everyone for joining us. Appreciate you taking some time to learn GitLab with us. And like I said, we'll be sending out the recording and the deck here the next day or so. Hope everybody has a good day.
Thanks, y'all.